so we're going to talk about the Pythagorean theorem. The Pythagorean theorem is a theorem that we use to find side lengths in a right triangle. So let's talk a little bit about right triangles. This, what I'm about to draw, is an example of a right triangle. Now, if it's just drawn like this, we cannot assume that it is a right triangle. You must need this little box in your triangle to say that it is a right triangle. That little box means that this is a 90-degree angle. And every right triangle, contains a right angle or a 90-degree angle. And that little box, again, remember, means that it's 90 degrees. Now, we have certain sides are called certain things. We will have something called the hypotenuse. The hypotenuse is always across from your right angle. So this side is the hypotenuse. And the hypotenuse, this is a very important part, the hypotenuse is always the longest side of your right triangle. Now the two other sides, or they're the two shortest sides, are called the legs. So this side would be a leg, and this side would be a leg. Your legs are always adjacent to your right angle. What the word adjacent means is that these legs are right next to and connected to this right angle here, which, as you can see in the figure, those legs are connected to the right angle. Whereas the hypotenuse is not touching the right angle, it's across from your right angle. So we're going to practice labeling the hypotenuse and the legs in the right triangle below. So the hypotenuse, remember, find your right angle. The hypotenuse is right across from it. We're going to use H for hypotenuse and L for legs. So if this is the hypotenuse, then this means that this is a leg and this is a leg. Those legs are connected or touching the right angle. The next one, find your right angle. The hypotenuse is right across from that right angle. So this would be your hypotenuse. The two other sides that are touching your right angle are your legs. And the last one, again, find your right angle. The hypotenuse is across from that right angle, and the two sides that are touching your right angle are your legs. A reminder that the hypotenuse is the largest side on your triangle. All right. Now, again, we're talking about the Pythagorean theorem. Some of you guys might be wondering, what is a theorem? A mathematical theorem is a mathematical statement that can be demonstrated to be true by accepted mathematical operations and arguments. Now, when mathematicians back in the day came up with these theorems, they weren't exactly known to be facts. All right, they needed to prove that their theorem or their mathematical idea was true. So when the Greek philosopher Pythagoras created the Pythagorean theorem, he also needed to prove that the Pythagorean theorem worked. Now, what do we use the Pythagorean theorem for? We use the Pythagorean theorem to find unknown side lengths of a right triangle. And now this theorem only works for right triangles. In order to use the Pythagorean theorem, we need to be given any two sides in our triangle. So for example, up here, if I was given the hypotenuse and this leg, I can use the Pythagorean theorem to find this other side length, this other leg. In this other one, if I was given the two legs in my right triangle, I could use the Pythagorean theorem to find that hypotenuse. So it doesn't matter what sides you have, you do need two sides in your right triangle. And so now we're going to look at the Pythagorean Theorem. It's a very famous formula that you might have already seen. The formula is a squared plus b squared is equal to c squared, where a and b represent your legs of your right triangle, and since addition is commutative, it does not matter what order your legs go in, but your c, the one that's isolated, is always your hypotenuse, your longest side on your right triangle. So let's get started. Number 1, what is the length of the hypotenuse of a right triangle with legs of lengths 9 centimeters and 12 centimeters? Well, your hypotenuse should always be the c in your formula. So we want to find c, whereas your legs will be your a and your b, and it doesn't matter which one you label a and which one you label b. I'm going to label the 9a and the 12b. But if you labeled the 9b and the 12a, that's completely fine. You would get the same answer, and that's because addition is commutative. So we are going to put this into the formula of a squared plus b squared equals c squared, and all we do is we substitute these numbers in. So my a is 9, so I'm going to have a 9 squared, plus my b is 12, so a 12 squared. And I don't know what my c is. I'm going to leave it as a c squared. That's what I'm trying to find. So when we're doing the Pythagorean theorem, we need to follow the order of operations, which states that we do exponents first. So a 9 squared is an 81 plus a 12 squared, which is a 144, and this equals a c squared. Continuing to follow the order of operations, we are going to add an 81 plus a 144, which is a 225, and that equals c squared. And then we're going to take the square root of both sides. Now 225 is a perfect square. In fact, you can use your perfect square sheet that I gave you in the last unit, the exponents unit. 225 is a perfect square. The square root of 225 is 15. So I get c is equal to 15, or 15 centimeters is my hypotenuse. Notice that my hypotenuse is the largest out of all 3 sides. All right, moving on to number 2. This time, I have my hypotenuse. My hypotenuse, again, is across from the right angle. That's your c. And we are trying to find a, so I'm going to label my 12 as b. So in my Pythagorean theorem, I have a squared plus b squared, which is going to be a 12 squared, is equal to c squared, which in this case is 15 squared. Solving this equation, I'm first going to simplify the exponents. So I have an a squared plus a 144 is equal to a 225. Subtracting 144 from both sides, I get a squared is equal to an 81. And taking the square root of both sides, 81 is a perfect square. The square root of 81 is 9. So I found my leg. All right, in number 3, we're first going to need to work with this right triangle here. On this right triangle, I do have my hypotenuse, which is across from my right angle. I always label that as C. I'm trying to find one of my legs, which I'm going to label as A, and I'm going to label my other leg as B. It doesn't matter which one you label A or B, but it does matter which one you label C. And we're going to do the Pythagorean theorem on this yellow right triangle. I have A squared plus B squared. My B is 3, so I have a plus 3 squared, is equal to my c squared, which is going to be 5 squared. So I have an a squared plus a 9 is equal to a 25. Subtracting 9 from both sides, I wind up with a squared is equal to a 16, and taking the square root of both sides, I wind up with a is 4 because 16 is a perfect square. So I'm going to put that back in to my figure, that a is 4. And now I'm going to work with this blue right triangle. Your right angle in this one is this right here because these two angles create a straight line. And 180 degrees is a straight line. 180 minus 90 gives you that the other angle is also 90. So in this blue right triangle, I'm trying to find my hypotenuse because that's the one that's across from my right angle. So I'm going to label my 6 as A and my 4 as B. And now I'm going to do the Pythagorean theorem again. So I have an A squared, which is going to be a 6 squared, plus a B squared, which is a 4 squared, is equal to my C squared, which is Y squared. So I have a 36 plus a 16 is equal to Y squared. A 36 plus a 16 gives me a 52, and that's equal to Y squared. Taking the square root of both sides, 52 is not a perfect square, so we are going to need to do a simplest radical form, which means we're going to simplify this radical. 52 is divisible by the perfect square of 4. 52 can be split up into 4 times 13. The square root of 4 is 2, so I take that 2 out and cross off the square root of 4. And the square root of 13 cannot be done. So I wind up with 2 root 13 as my final answer. All right, looking at number 4, we're first going to look at this red right triangle. I have my hypotenuse, which I'm going to label as C. I'm trying to find one of my legs. I'm going to label that one as A and my other one as B. So I have an A squared plus a B squared, or a 2 squared, is equal to my C squared, which is a 7 squared. So I really have an A squared plus a 4 is equal to a 49. I'm going to subtract 4 from both sides to get A squared is equal to a 45. And taking the square root of both sides, since this is not a final answer, it's actually a lot easier to not simplify this radical and to leave it as the square root of 45. So I'm going to leave this as the square root of 45, and I'm going to show you why it's super simple to not simplify that in a moment. Now I'm going to use this pink right triangle, and on this pink right triangle, the square root of 45 is actually my C value. I'm going to label my 5 as my A and my X as my B. So now I'm going to do the Pythagorean theorem again. I have a 5 squared plus an X squared is equal to the square root of 45 squared. A 5 squared is a 25 plus an X squared. Now here's why it's super simple to leave this as the square root of 45 squared, is because the square root of 45 squared is just a 45. You just get rid of your radical. Subtracting 25 from both sides, I wind up with an X squared is equal to a 20. And taking the square root of both sides, I'm not going to leave it as the square root of 20 because this is a final answer. So I am going to simplify. 20 can be split up into a 4 times a 5. The square root of 4 is a 2, so I'm going to take that 2 out. The square root of 5 cannot be done, so that remains. That's my final answer. Lastly, the converse of the Pythagorean theorem states that you are given a triangle and you need to show that it is a right triangle by doing a squared plus b squared equals c squared. You do need to know that your c is always the longest side. So in number 5, my c should be labeled as this 52. It does not matter which other one is labeled a or b. But we actually do the Pythagorean theorem, a 20 squared plus a 47 squared equals a 52 squared. And we get that the left side is a 2,609 and the right side's a 2,704. So since both sides don't equal one another, then this is not a right triangle. I'm going to have you continue to the next video to get